Alright, welcome to 12.2. Our learning target today says that you will be able to identify excluded values of rational functions and graph rational functions. So, a rational function is a function whose rule is a quotient of polynomials in which the denominator has a degree of at least 1. In other words, there must be a variable in the denominator. So here we have some examples of y equals 2 over x, y equals 3 over 4 minus 2x, and y equals 1 over x squared. So notice all the variables in the denominator. So an excluded value is any x value that makes the function value y undefined. For a rational function, an excluded value is any value that makes the denominator equal to 0. So now we're going to learn how to find an excluded value for these functions. So here we set our denominator equal to 0, so we get x equals 0. So our excluded value is 0. Over here we'll set our denominator equal to 0, so we have x plus 3 equals 0. Subtract 3 from both sides, so x equals negative 3. So our excluded value is 0. Oh, I'm sorry, it is negative 3. So most rational functions are discontinuous functions. Meaning their graphs contain one or more jumps, breaks, or holes. This occurs at an excluded value. One place that a graph for a rational function is discontinuous is at an asymptote. An asymptote is a line that a graph gets closer to but never crosses. So in this graph down here, we can see that the x and y axes are asymptotes. So if you look, it gets really, really close to the y-axis but doesn't ever touch or cross it. And it gets really, really close to the x-axis but never touches or crosses it. For rational functions, vertical asymptotes will occur at excluded values. So now we're going to find the asymptotes. So we can rewrite or write a rational function in the form of y equals a over x minus b plus c. Okay, so that is our equation. Vertical asymptotes will be at b, and horizontal ones will occur at c. So here on the left, we can write this equation in that form. So we'll have y equals 1 over x minus 6 plus 0. So our vertical asymptote will be at that excluded value. So x minus 6 equals 0. Therefore, x equals 6. And our horizontal asymptote is going to be at that c value. So at y equals 0. So here we're going to find our excluded value for this equation on the right. So we'll set our denominator equal to 0. So we have 3x minus 10 equals 0. 3x equals 10. So x equals 10 over 3. So now we're going to find our horizontal asymptote. So this is going to be our vertical asymptote. Our horizontal asymptote is going to be that c value. So c value here. So horizontal asymptote is y equals negative 7. So now we're going to graph the rational functions using the asymptotes. So we're going to find the vertical and horizontal asymptotes. So vertical will be at x minus 2 equals 0 is how we're going to find that excluded value. So x equals 2. So there's our vertical asymptote. Our horizontal asymptote will be at that c value. Which is y equals negative 4. So now we're going to graph our asymptotes using dashed lines. So asymptotes are usually like invisible on a graph, so that's why we're going to graph them using dashed lines, so we know where they are when we're creating our graph. So if you go down here, our asymptotes we said would be at 0, where did we say it was going to be? We said it was going to be at, oops. So we said our vertical asymptote was going to be at x equals 2. So you'd graph that just like this. And our horizontal asymptote was going to be at -4. So that's how you would draw those asymptotes. Alright. So now we're going to make a table of values and choose. We're going to choose x values on both sides of the vertical asymptote. So our vertical asymptote was that +2. So let's choose Alright, so I chose some x values. I chose 3 and 4, which is on the right side of our vertical asymptote, and 1 and 0, which is on the left side of our vertical asymptote. So when we plug that into our equation, so to remind you, it was y equals 1 over x minus 2 minus 4. So when we put 3 in there, we get 1 over 3 minus 2, which is 1, so 1 over 1 minus 4. So 1 minus 4 is -3. Then we have 1 over 4 minus 2, so 1/2 minus 4 is -3.5. Then when we put 1 in there, we have 1 over 1 minus 2. So that's -1 minus 4 is -5. And 1 over 0 minus 2, so 1 over -1/2 minus 4 is -4.5. So those are the values that I chose. Now I'm going to put them in our graph down here. Oops. So these are my values. Alright. So our asymptotes were at x equals 2. So I'll redraw that back in quickly, and y equals -4. So remember, those are the lines that the curve will not touch. So let's plot our points. So first I had 3, -3. So negative. 4, -3.5. -5. Or 1, I'm sorry, 1, -5, and 0, -4.5. So I'm going to redraw those in another color so they're easier to see apart from the asymptotes. So our curve is going to look something like this. So it'll get close to those but never touch them. So that's what your picture should sort of look like.